Hello friends, today we are going to talk about the introduction to Python, and in this particular topic we are going to cover the key concepts of Python. My name is Vishal Jain and I belong to Symmetrics Consulting Private Limited. You can reach me on https://symmetrics.io. So let's start our agenda for today, that is introduction to Python. Before we get into the Python, we have to understand what is computational thinking. So computational thinking is all knowledge that can be derived or which is imperative. What is declarative? Declarative thinking is that statement of fact. For example, we give a statement that value of pi is 3.14. We just declare the value of pi, that is 3.14, but we do not tell how we calculate the value of pi as 3.14. We don't tell how do we arrive to this value. That's known as declarative knowledge. Imperative knowledge is where we give the instructions on how to reach that fact. How do we calculate and give the complete instructions step by step to the computer, how the computer can calculate the value of pi as 3.14. So that is known as imperative thinking. Now let's come to algorithm. Algorithm is bit like a recipe from a cookbook. For example, when we give a recipe, we give the instructions to the someone who is preparing the recipe step by step. For example, like first curd mixture over heat, then stir, then deep spoon in custard, remove spoon and run finger across back to the spoon, back of spoon. If clear path is left, remove custard from heat and let cool, otherwise repeat. So this kind of instructions when we give for in case of recipe from a cookbook, this is known as algorithm. So the algorithm includes some tests for deciding when the process is complete, instructions about the order in which to execute the instructions, and jumping from some instructions based on a test. So this is known as algorithm. Now let's come to the primitives. There are two kind of primitives. One is literals and second one is operators. So literals are like numbers. We can define numbers as 1, 2.5, 3, etc. And operators. They are like a mathematical or logical operators. For example, operators like a plus operator. The use of plus operator is to sum two numbers. Minus operator, the use of the minus operator is to subtract two numbers. Similarly, we have multiplication operator which multiplies two numbers and division operator which divide one number from other number. And then we have logical operator like AND, OR, etc. Computer programs. So there are two kind of computer programs. One is fixed computer program and second is program computers. So what are fixed program computer? Fixed program computers are designed to do very specific thing. For example, to calculate the area of a uh, to calculate the area of a circle. So this is known as the fixed program computer. But there's stored program computer also. Stored program computer are predefined instructions stored in a electronic memory. This example is a simple calculator. Like this simple calculator has a predefined set of instructions on what to do if the user input 2 plus 5. So it just gives us the answer. So they are known as stored program computer. Now let's come to the set of primitive constructs: syntax, static semantic and semantic. So syntax is the programming like a grammar of the program. So as in case of English or any other language, we have the words which are connected to form a sentence, and there are some grammar rules which define whether the sentence is valid or not. For example, a typical sentence has a subject plus verb plus object. Like cat, boy, dog is not a valid syntax because it's noun plus noun plus noun. But when we say boy eats food, so it's a valid syntax because it has a subject, then it has a subject, and then it has a verb, and then it has a object also. So it's a valid syntax. In Python, sequence of primitive like 5.2 plus 5.2 is a valid syntax, but 5.5 space 5.5 is not a valid syntax. Next comes the static semantic construct. So these are the syntactically valid statement, but they should have a valid statement. For example, in English, when I say I tall here is syntactically correct because it has a sequence like noun and there is a linking verb here and then there is a object adjective. So these are the syntactically correct, but it's not a valid English. Similarly, in Python, 1 oblique ABC is syntactically correct because it has a literal plus operator, division operator plus a literal, but it can produce the semantic error. Now, static semantic error. Now comes to the semantic error. As each statement that can be a syntactically correct, but it does not have any static semantic error also, but it should have one single meaning with a sentence. So our program should be able to return only one output, and that should be the desired output. So that is known as semantic. So example, I cannot praise this student too highly. There can be two meaning, one in case of sarcastic sense and second is the true sense. So our program should have exactly one meaning. Now let's come to the type of error. So there are again three type of errors. One is syntax, static semantic and semantic. What are syntax error? These are the most common type of error because these are least dangerous kind of error. So if the program has any syntax error, the programming languages will check the syntax error and they will not allow user to execute the program even with a single syntax error. In most programming language, the location of the error is also given. So these are the very simple error to handle because beforehand you know where the error is and why the error is. The more complex type of error are static semantic error. So programming language like Java does lot of checking on static semantic error before the program is allowed to execute. But Python does not catch all static semantic error. So the behavior of the program which has static semantic error are unpredictable. So due to this reason, Python is not optimal for language which are high reliability constraints. Next one is semantic. If the program has no syntax error and no static semantic error, it is considered to have no semantic error. But it may have some semantics as the programmer wants to have when a program means something other than the what programmer thinks and its behavior is very strange. Sometimes while working on a program, we can come up with a program which is syntactically correct and static semantically correct, but it does not give us the desired output. So that kind of errors are very difficult to find out. So next is what happens if the program behaves in an unintended way. So there are three possibilities. Number one, the program may crash. Number two, it might keep on running and never stops. And third is that it might give us an answer which may not be an expected answer. So this is the most dangerous part, and sometimes lot of codes when they are not tested properly, they move to production, and in production they don't give us the desired output and then we call them bugs. Next topic in today's agenda is high level versus low level programming language. So what are high level programming language? High level programming language is close to human language. So no particular knowledge of hardware is required for high level programs. They are portable. They are far from machine code, and examples are Python, Java and C++. Next comes the low level programming language. So low level programming language uses instructions and objects at the machine level. They are related to specific architecture and hardware, and the examples are assembly language and machine code. So here the clear-cut example is like Python. We don't need any machine level programming, and it can be programmed on any platform, and it can be ported from one program from one platform like Windows to uh, Linux and Linux to Windows, vice versa. And they are into the human close to human language. We can understand it very well by reading it. But low level programs are user instructions and they are written at the machine level. General and targeted, whether the primitive operations are widely applicable or fine-tuned to one particular domain. That is, for example, Adobe Flash is used for graphics for web pages but cannot be used for some purpose like stock portfolio analysis. General language like Python can be used in multiple areas for multiple purposes. So there's a difference between general versus targeted language. Interpreted versus compiled language. So whether the source code is executed directly by interpreter or whether the source code is first converted into a sequence of machine level primitive by compiler and then it can be used. So interpreted languages are easy to debug, whereas the compiled languages are quickly run and use language spaces. So to summarize, in this session we have covered the key concept of declarative and imperative type of knowledge, algorithms, primitives, literals and operators. Then we covered fixed computer programs and stored program computers. Then we covered the set of primitive constructs, syntax, static semantic and semantic. Then we covered the three type of errors: static semantic and semantic errors. And then we talked about the high level and versus low level programming language, general versus targeted programming language, and interpreted versus compiled language. So I hope this was a good session for you. Thank you.